Hello everyone, welcome back to Husky Math. So far we have covered the differentiation part of calculus. Now it's time to move on to the other major branch of calculus, that is integration. So in this chapter we will begin indefinite integral. So indefinite integral is just the reverse of differentiation. Let us consider a function sine of x. If we differentiate this function sine x with respect to x, then we will get cos of x. Now if we integrate this cos of x with respect to x, then we will get sin x. But while integration, here we have to add a constant and let us call it as c. Now there's a reason why to write this constant here, because if I consider a function, let's say sin x plus 5, and I differentiate this function with respect to x, then I'll get cos of x and ddx of 5 is again 0. That means the derivative of sin x plus 5 is also cos x. One more time, if I consider a function sin x plus 6, and if I differentiate this function with respect to x, then again this time also I'll get cos of x. That means integration of cos x could be sin x, integration of cos x could be sin x plus 5, the integration of cos x could be sin x plus 6. That's why integration of cos x in general we will write sin x plus c, and this c is called constant of integration. So in general, if the derivative of a function f of x is equal to small fx, then integration of small fx will be capital Fx, but with constant of integration. So here the function that is getting integrated is called integrand, and this is called constant of integration. Now since this constant of integration could be any number or anything, that's why the value of c is indefinite, and that's why this integration is called indefinite integral. So there are some basic formulas in the first box, that is integration of x to the power n dx is equal to x to the power n plus 1 over n plus 1 plus c. And similarly there are other three formulas here. And in the second column, if you see, I have highlighted only the integration of sin x and cos x for now. The rest, tan x, cosec x, sec x and cot x, you can copy it here also, but we will discuss these four formulas later in the chapter. And in the third column you have more formulas which you have to remember. So without wasting any time, let's get started with some questions. Integrate x to the power 7 with respect to x. Now in order to integrate this function, we have formulas which I have written here, that is x to the power n dx. Here it's clear that the value of n is 7. So by looking at this formula, this can be written as x to the power n plus 1 divided by n plus 1 plus constant of integration. So this equals to x to the power 8 by 8 plus c. Question number 2. Integrate 2 over x squared with respect to dx. Before integrating this, let me talk about some properties which you have to remember. And that is, if there is a function fx getting multiplied with some constant k, and if I have to integrate this with respect to x, then it will be k times integration of fx dx. So this means the whatever constant is getting multiplied with the function, that constant can be taken out of this integration. This is the property 1 which you have to remember. And let me write property number 2 also. If there are two functions of x, let us say fx and gx, and if they are getting added, and if I have to integrate this function, then the integration can be distributed to individual functions like this. So integration of gx dx. These two properties you have to remember. Now since in question number 2 there is a constant 2 here, so I can take out this 2 outside the integration using the property 1, then here it will be 2 integration of 1 by x square dx. This equals to 2 integration of 1 by x square is x to the power minus 2 dx. Now again, this is in the formula number 1, that is x to the power n dx. So using the formula, it will be 2 times x to the power minus 2 plus 1 divided by minus 2 plus 1 plus constant of integration. So this equals to 2x to the power minus 1 over minus 1 plus c. And hence this can be written as minus 2 x to the power minus 1 can be written as 1 by x plus c. Question number 3. Integrate cube root of x square. So here this function can be written as x square to the power 1 by 3 dx equals to integration of x to the power 2 by 3 dx. Here the value of n is 2 by 3. Now using the formula, it equals to x to the power 2 by 3 plus 1 whole divided by 2 by 3 plus 1 plus constant of integration equals to x to the power, if you add then it will be 5 by 3 divided by 5 by 3 plus c. So this equals to 3 over 5 x to the power 5 by 3 plus c. Question number 4. Integrate this function. Here inside the bracket there are 1, 2, 3, 4, 5 terms. So first let us distribute the integration. So this equals to integration of square root of x dx minus integration of cube root of x to the power 4 dx plus integration of 7 by cube root of x square dx minus integration of 6 e to the power x dx plus integration of 1 into dx. So this equals to integration of x to the power half dx minus integration of, this can be written as x to the power 4 by 3 dx plus, here 7 is constant, let us take it outside, and here it will be 1 by x to the power 2 by 3 dx minus 6 is constant, e to the power x dx plus 1 into dx is simply dx. So let us use the formula 1. Here the value of n is 1 by 2. So here it will be x to the power n plus 1 divided by n plus 1 minus x to the power n plus 1 divided by n plus 1 plus 7. Here 1 over x to the power 2 by 3 is x to the power minus 2 by 3. So using the formula here it will be x to the power minus 2 by 3 plus 1 by minus 2 by 3 plus 1 minus 6 into integration of e to the power x from formula is e to the power x only. So here we will write integration of e to the power x is e to the power x only plus integration of dx, you remember integration of 1 dx is always x. And since for each and every term there will be constant of integration, but all those constants are get added and we will write one constant of integration for all integrals. So now let us simplify this, then this will be x to the power half plus 1 is 3 by 2 divided by 3 by 2 minus x to the power 4 by 3 plus 1 will be 7 by 3 divided by 7 by 3 plus 7 x to the power 1 minus 2 by 3 will be 1 by 3 by 1 by 3 minus 6 e to the power x plus c. So on simplifying it will be 2 by 3 x to the power 3 by 2 minus 3 by 7 x to the power 7 by 3 plus 1 by 3 will be 3, and 7 times 3 is 21, x to the power 1 by 3 minus 6 e to the power x plus c. So this is the final answer. Question 5. Integration of x to the power 6 minus 1 over x squared plus 1. So before integrating, let us divide x to the power 6 minus 1 with x squared plus 1. And before that, let us assume the question as I. So let I equals to integration of x to the power 6 minus 1 by x squared plus 1 dx. Now let us divide the given function, that is x to the power 6 minus 1 by x squared plus 1. So on dividing, x squared into x to the power 4 is x to the power 6, and 1 into x to the power 4 is x to the power 4. So let us subtract here. So then we will have minus x to the power 4 minus 1. Now x squared minus x squared is minus x to the power 4, and 1 into minus x squared is minus x squared. Changing the sign, these two got cancelled, then I'll have x squared minus 1. Now x squared plus 1 will be x squared, and plus 1 into 1 is 1. So this equals to, changing the sign, so here I'll have remainder minus 1 and minus 1, that is minus 2. That means if I divide x to the power 6 minus 1 with x squared plus 1, then this function I can be written as, therefore I can be written as integration of the quotient, that is x to the power 4 minus x squared plus 1, x to the power 4 minus x squared plus 1, and the remainder, that is minus 2 over x squared plus 1, that is minus 2 over x squared plus 1, closing the bracket, dx. Now let us distribute our integration, then here it will be integration of x to the power 4 dx minus integration of x squared dx plus integration of 1 into dx is dx minus 2 is constant, so let us write 2 here, and integration of 1 by x squared plus 1 dx. So using the formula, then this will be x to the power n plus 1 by n plus 1 minus x to the power n plus 1 by n plus 1 plus integration of dx is x minus 2 into, now look at this function, that is 1 by x squared plus 1. So this is in the formula of this, and it will be tan inverse of x plus c. So my final answer will be x to the power 5 by 5 minus x cubed by 3 minus x minus 2 tan inverse of x plus c. Question 6. Integrate 9 sin x minus 7 cos x minus 6 over cos square x plus 2 over sin square x plus cot square x dx. So first, let us separate the integrals. Then it will be integration of 9 is constant, sin x dx, minus 7 is constant, integration of cos x dx, minus 6 is constant, integration of 1 by cos square x dx, plus 2 is constant, integration of 1 by sin square x dx, plus integration of cot square x dx. So my integral equals to 9. Integration of sin x dx is minus cos x minus 7 into integration of cos x is sin x minus 6. Integration of 1 by cos can be written as sec, so here it will be sec square x dx plus 2 times integration of 1 by sin is cosec square x dx plus, now we do not have the direct formula for cot square of x dx. So for that, let us replace cot square x with the identity cosec square x minus 1 dx. So this one identity, that is cosec square x minus cot square x equals to 1. So from there, I wrote cot square x as cosec square x minus 1. So my integral I will be equal to minus 9 cos x minus 7 sin x minus 6. Integration of sec square x is tan x from the formula, plus 2 into integration of cosec square x is minus cot x, plus here we distribute integration of cosec square x dx minus integration of 1 dx. Hence my answer will be minus 9 cos x minus 7 sin x minus 6 tan x minus 2 cot x. Integration of cosec square x is minus cot x, and integration of minus dx is minus x plus c. So at last, you don't forget to write the constant of integration. So here we can add these two terms, then there will be minus 3 cot of x in our answer. Question 7. Integrate 1 plus 2 sin x over cos square x. So here let us distribute the denominator, then we will have 1 by cos square x plus 2 sin x over cos square x dx. So this equals to integration of 1 by cos is sec square x plus 2 sin x by cos square x can be written as cos x into cos x. So this equals to integration of sec square x plus 2 sin over cos is tan and 1 over cos is sec dx. Now let us separate the integral sec square x dx plus 2 is constant, integration of sec x tan x dx. Now since integration of sec square x from formula is tan x, and the integration of sec x tan x is sec x, so it will be plus c at last. Question 8. Integration of sin x over 1 minus sin x dx. So before integrating, let us rationalize the denominator here. So it will be one minus sin x into 1 plus sin x dx equals to, opening the bracket, sin x plus sin square x divided by a plus b into a minus b is a square minus b square equals to sin x plus sin square x divided by, we know that 1 minus sin square x is cos square x. Now let us separate the denominator, then we will have integration of sin x by cos square x plus sin square x by cos square x dx. So this equals to integration of, see, there is cos square x at denominator, so sin x by cos x can be written as tan x, and 1 by cos x will be sec x, plus sin by cos is tan, so there it will be tan square x dx. Now let us separate the integral, then we will have integration of sec x tan x dx plus integration of tan square x dx. The integral of sec x tan x is sec x, but since we do not know the integral of tan square x, so we will replace tan square x in terms of sec square x. That can be written as sec square x minus 1 dx equals to sec x plus integration of sec square x dx minus integration of 1 dx. Now since we have the value of integration of sec square x, that is tan x, so here it will be tan x, minus integration of dx is x plus constant of integration. Question 9. Integrate 1 over 1 minus cos 2x. Here I have listed some formulas from trigonometry from the chapter half angles. So here, before integrating, let us replace this function which is given in the question, that is 1 minus cos 2x, from the formula, that is from this portion. So from here we can write integration of 1 over 1 minus cos 2x can be written as 2 sin square x dx. Now since 1 by 2 is constant, we will take it out, and 1 by sine is cosec square x. And we know that integration of 1 cosec square x is minus cot x plus constant of integration. So it will be minus 1 by 2 cot of x plus c. Question 10. Integration of cos inverse of 1 minus tan square x over 1 plus tan square x dx. See, if you notice here, outside there is cos inverse. So here whatever is inside the bracket, we have to turn this function in terms of cos so that we can make the function simpler. Now if you notice from the formula of multiple angles, then 1 minus tan square x over 1 plus tan square x can be written as cos 2x. So let us directly replace this, then we will have cos inverse of cos 2x dx. And since we know that cos inverse of cos theta is theta only, then here it will be integration of 2x dx. Taking out 2 common, we will have integration of x dx. And using the formula, then we will have 2 into x to the power 1 plus 1 divided by 1 plus 1 plus constant of integration, since the value of n was 1 there. So this equals to 2x square by 2 plus c. So 2 and 2 got cancelled, hence my answer will be x square plus c. Question 11. Integrate tan inverse of square root of 1 minus sin x over 1 plus sin x. So here also we have to convert this everything in terms of tan. So before that, let us convert this sine into cos. So here this equals to integration of tan inverse of square root of 1 minus the c. Sin x can be written as cos 90 minus x over 1 plus cos 90 minus x, because cos 90 minus x is sin x only. On doing so, now we have one formula from multiple angles, that is cos of 2x. So here if you see cos 2x equals to 2 cos square x minus 1. So if I rewrite this formula, then here I can write 1 plus cos 2x as 2 cos square x. And from this formula I can write 1 minus cos 2x equals to 2 sin square x. So these two formulas are very important. Whenever you see 1 plus cos 2x, then you always try to replace with 2 cos square x. And whenever you see 1 minus cos 2x, you will write 2 sin square x. So here inside the square root, I can see that there is 1 minus cos of x. So this is in the form of this 1 minus cos 2x. So here if I have to write the value of 1 minus cos pi by 2 minus x, then it will be 1 minus cos pi by 2 minus x can be written as 2 sine square pi by 2 minus x whole divided by 2. Now see here, if you notice that whenever there is 2x, then here it is x only. That means this x is half of this 2x. So similarly, the half of this angle will be pi by 2 minus x over 2. That's why I'm dividing it by 2. And if I simplify this, then this can be written as 2 sine square 1 by 2 into pi by 2 minus x. So this can be written as 2 sine square pi by 4 minus x by 2. That means the value of 1 minus cos pi by 2 minus x can be written as 2 sine square pi by 4 minus x by 2. So let us write it here. So this equals to integration of tan inverse of square root of 2 sine square pi by 4 minus x by 2 divided by, similarly here in denominator, if you see, there is 1 plus cos pi by 2 minus x, and similarly looking at this formula, that is 1 plus cos 2x, I can write this as 2 cos square x. And since there is the half of 2x, so here also I have to write the half of this angle, and that would be pi by 4 minus x by 2. So here in denominator I can write this as 2 cos square, the half of that angle is pi by 4 minus x by 2 dx. So here 2 and 2 got cancelled, equals to integration of tan inverse of square root of, see, sine over cos, and the angles are same, that's why I can write that as tan square pi by 4 minus x by 2 dx. And here this is square root and this is square got cancelled, so this equals integration of tan inverse of tan pi by 4 minus x by 2 dx. And since tan inverse of tan theta is theta only, so it will be pi by 4 minus x by 2 only. Now it's very easy to integrate. Let us separate the integration, then it will be integration of pi over 4 dx minus integration of x by 2 dx. Since pi over 4 is a constant, so let us take it out and it will be integration of dx only, minus half is constant and x dx equals to pi over 4 integration of dx is x minus half into integration of x is x squared by 2 plus integration constant, hence it will be pi by 4x minus x squared by 4 plus c. Question 12. Integration of sine to the power 6x plus cos to the power 6x over sine square x into cos square x dx. So here we will write this sine to the power 6 as sine square x whole cube plus cos square x whole cube whole divided by sine square x cos square x dx. Now this is in the form of a cube plus b cube, and for that we have a formula. So from formula we can write this a cube plus b cube as a plus b whole cube minus 3 into a b times a plus b whole divided by sine square x cos square x. Now since sine square x plus cos square x is 1, so we will have 1 cube, that is 1, minus 3 into sine square x cos square x in numerator whole divided by sine square x cos square x dx. So here I forgot to write dx. Now let us separate the denominator, then we will have integration of 1 by sin square x cos square x minus 3 times sin square x cos square x divided by sin square x cos square x dx. So here sin square x cos square x got cancelled. So this equals to, now again in place of this particular 1, let us write sin square x plus cos square x whole divided by sin square x cos square x. So instead of that 1, I wrote sin square x plus cos square x minus 3 dx equals to, now let us again separate the denominator here, then we will have sin square x by sin square x cos square x plus cos square x by sin square x cos square x minus 3 dx. So here sin square x got cancelled, cos square got cancelled. So this equals to integration of 1 by cos square x can be written as sec square x plus 1 by sin square x can be written as cosec square x minus 3 into dx. Now let us distribute the integration, then we will have integration of sec square x dx plus integration of cosec square x dx minus 3 is constant, so integration of dx only. And integration of sec square x is tan x plus integration of cosec square x is minus cot x minus 3. Integration of dx is x plus c. Question 13. Integrate 3 sin x plus 4 cosec x whole square with respect to x. So here first we will evaluate this using a plus b whole square. So then we will have integration of a square, that is 9 sin square x plus b square, that is 16 cosec square x plus 2ab will be 2 3s are 6, 6 4s are 24, 24 sin x cosec x dx. So let us distribute the integration, then we will have 9 is constant, integration of sin square x dx plus 16 is constant, integration of cosec square x dx plus 24 is constant, integration of, now if you look at this part, that is sin x into cos x, that will be equal to 1, because sin x into cosec x is sin x into 1 by sin x, because cosec and sin are inverse of each other, so there we will get only 1. So here it will be only dx. This equals to 9 integration of, now since we do not know the value of integration of sin square x dx, so for this we will again use multiple angles, and we have that one formula, that is this, and from here we can write this as 2 sin square x as 1 minus cos 2x. So from here sin square x can be written as 1 by 2 into 1 minus cos 2x. So we will replace this formula in terms of sin square x, then it will be 1 by 2 into 1 minus cos 2x dx plus integration of cosec square x is minus cot x plus 24, integration of dx is x. So this equals to 9 by 2. Let us separate integration again, then we will have integration of 1 dx minus integration of cos 2x dx minus 16 cot x plus 24x. This equals to 9 by 2 integration of dx is x minus integration of cos 2x. We have one formula, that is integration of cos mx dx, where m is any number, then this can be written as sin mx by m plus c. So this formula we will discuss in the upcoming videos. For now, integration of cos 2x using that formula can be written as sine of 2x by 2 minus 16 cot x plus 24x plus constant of integration. So here it will be 9 by 2x minus 9 by 4 sine 2x minus 16 cot x plus 24x plus c. Here you can simplify these two terms, then you will have 57 by 2x minus 9 by 4 sine 2x minus 16 cot x plus c. Question 14. Integrate cos x plus a over sine x plus b dx. Here the angles are different, x plus a and x plus b. So here I will try to make the angle same by adding b and subtracting b inside cos. So let us add b by myself, and to balance let us subtract b whole divided by sine x plus b. So here in numerator I added and subtracted b. Now let us consider this x plus b as one angle and a minus b as another angle. So let this be my capital A and let this be my capital B. And now this is in the form of cos a plus b. For that we have one formula from trigonometry, that is cos a plus b equals to cos a cos b minus sin a sin b. So here we will be using that formula to evaluate the numerator. So this equals to integration of cos a cos b minus sin a sin b whole divided by sin x plus b. Here one thing we have to note, that this small letter a and b are constants. The variable is x. So now let us separate the denominator, then we will have integration of cos x plus b cos a minus b divided by sin x plus b minus sin x plus b into sin a minus b whole divided by sin x plus b dx. Now as you can see here, sin x plus b and sin x plus b got cancelled, and we have cos x plus b over sin x plus b. Now we can write this as cot x plus b. So this equals to integration of cot x plus b into cos a minus b minus sin a minus b dx. Now let us separate the integration, then we will have integration of cot x plus b into cos a minus b dx minus integration of sin a minus b dx. As I told you earlier that a minus b are constant, so here cos a minus b and sin a minus b are constant. So let us take it outside the integration, then we will have cos a minus b integration of cot x plus b dx minus taking sin a minus b outside, we will have integration of dx equals to cos a minus b. Till now, we do not have the formula for cot x dx. But in the next section, we will learn the formula of integration of cot x dx will be integration of cot x dx is log of modulus of sin x plus c. So here we will use this formula to write the value of this. So it will be log of sin x, and here we have x as x plus b, so that's why we will write x plus b minus sin a minus b into integration of dx is x plus c. Hence my answer will be cos a minus b into log of modulus of sin x plus b minus x into sin a minus b plus c. So this is the answer for this question. See, the formula for cot x dx is log of sin x, but instead of x there was x plus b here, and for that I wrote the integral of it as log of sin x plus b. So why I wrote the x plus b, this we will be discussing in the coming lessons. For now, you just note that inside this cot function there is x plus b, which is a linear polynomial, and whenever there is a linear polynomial inside this, you can directly replace x with x plus b. So this much in this video. We will be learning more about integration in the coming videos.